started. So good morning everyone and welcome to this session. So my name is Victor Isakov. I'll have a little bit of a slide about myself, how you can contact me for any further questions, etc. But basically what we're doing this morning is having a look at a session on what SharePoint admins need to know about SQL Server. So I'm more of a SQL Server person, so I'm not a SharePoint expert, but I'm more of a SharePoint infrastructure expert. So I have worked on SharePoint projects where we're sort of doing the high availability, the capacity planning for SQL Server, the configuration, those sorts of things like that. Okay. So if you have any questions, we might save them to the end of the session because of time constraints. Otherwise, feel free to contact me via any one of these mechanisms. I do have a blog, there's nothing on it. The company website, in our case www, stands for the world's worst website, so again, you won't find too much there, unfortunately. It's all a work in progress. I tend to be very busy with things other than websites and internet stuff, so as I said, remember Victor at sqlserversolutions.com.au, so fire off any questions if you'd like. We'll see how we go with that, so we can certainly answer questions, that's free. So the point of this particular presentation is to talk a little bit about the SQL Server side of things for SharePoint, because we do health checks for SQL and do health checks for SQL Server running SharePoint farms, and you sort of tend to notice the industry worst practices, if you like, there. So people aren't doing certain things for their SQL Server environments. The better your SQL Server environment runs, the better your SharePoint environment will run. So again, there's a very, very strong dependency and link between the two technologies. So the idea behind this particular presentation was just to talk a little bit about what, as a SharePoint admin, you should be thinking about as far as SQL Server is concerned there. So I just wanted to have there's going to be no demos, but just talk a little bit about some initial planning, some general thoughts and those sorts of things. And then what we're going to do is just go through the configuration of SQL Server, the administration of SQL Server, and also talk a little bit about availability. Because a lot of organizations don't think about availability. They think that a good backup strategy might be the equivalent of a high availability strategy, and that's not the case. Later on this afternoon, I think at 3 p.m, we're going to have another session which is going to talk a little bit about the high availability options that you have for SharePoint as far as SQL Server is concerned, so concentrating on the SQL Server technology stack. So we're going to go through all of that, so I invite you to come back this afternoon. So we're going to go through that sort of process of here are the strengths, the pros and the cons of the different high availability solutions that are available to SQL Server. So we're not going to concentrate too much on availability for this particular session. So the first thing I just wanted to do was just sort of start the conversation rolling, some random initial thoughts. So the first point I really wanted to make was the fact that SharePoint is just another database as far as SQL Server is concerned. There's nothing special about SharePoint in most cases, okay? So a lot of theory that you would have that applies to good practices, configuration, etc., for a database inside SQL Server would generally also apply to SharePoint. There's going to be the odd exception, and you do need to optimally configure SQL Server for SharePoint, but again, there's nothing so magical and mystical and weird about SharePoint that good practices don't apply in general, okay? There's lots of bad and weird advice out there as well, okay? Some from really interesting sources that, again, are probably more of an expert in SharePoint, but don't really know the SQL Server side as much. So what I'm trying to do inside this particular presentation is give you a platform for configuring your SQL Server environment, optimally for SharePoint. And just wanted to point out, people are always worried about performance. And you're going to get the biggest bang for your buck in terms of performance by doing some very, very simple things correctly. So you do some standard things correctly inside SQL, you're going to account for 80% of your performance gains. And then if you want that last 20%, then we start to get into the exotic things and the real minutiae of configuring things correctly. But some really good, simple best practices will go a long way as far as good performance, reliability, robustness, availability are concerned, etc. So I just wanted to talk a little bit about some initial planning in general. So just observations from what I see inside the industry. Again, this is something that I see a lot of in the industry where people are, not planning their SharePoint infrastructure, their SQL Server infrastructure correctly from the start. And this is like their third attempt to get SharePoint right. So they're sort of spending a lot of time, energy, etc. into developing a solution. It doesn't get anywhere, so they destroy it, start again. They're up to their third attempt, so it's not an uncommon scenario inside the environment. So just really wanted to point out as a generic thought that, you really should be spending a little bit more time initially planning the SharePoint environment. And even from the SQL Server point of view, I've worked with systems where it was like 1.2 million users, 6 petabytes of storage. For those kinds of environments, you obviously need to do the capacity planning, the hardware planning, etc. for the SQL Server environment. For such large SharePoint solution, you need to make sure that you do it correctly there. So again, I just wanted to point out that in terms of design, something that maybe the industry doesn't do too well, but we should be looking at requirements gathering. And we'll talk a little bit about capacity planning, but that's very, very important as far as SharePoint is concerned from a SQL Server point of view. So again, if you have SQL Server DBAs in a larger organization and you're about to deploy a solution there, they'll be asking you all sorts of questions. What are the transactions per second that we're expecting? Is it an OLTP environment? Is it a decision support environment? What's the IOPS that we're expecting, etc. So I want people to go away thinking about these sorts of things. We're going to implement SharePoint on SQL. We need to know something about how SharePoint works with SQL Server so that we can better design a solution as well. So we'll talk a little bit about capacity planning. Defining service level agreements. So that's from an availability point of view, but it's also from a performance point of view as well. So again, you need to define some SLAs around uptime, performance possibly as well. So we'll talk a little bit about that. But availability is often overlooked inside organizations. And then as you can see also then that allows you to scope the hardware correctly, hopefully implement a proof of concept, those sorts of things there. Always a good idea to understand the technology, so understand how SQL Server works because you'll be better able to design a solution if you like there. So just wanted to make some initial points in capacity planning. So again, capacity planning from a SQL Server point of view goes a long way. And when we're talking about capacity planning, a lot of people in an organization straight away focus on storage capacity. So how big are the databases going to be, etc. And that's certainly a valid way of doing things, but you should also think of capacity as far as processor subsystem, the memory subsystem as well there. You also need to understand what the different versions of SQL Server and Windows do because they'll have different capacity. They will support different maximum amount of memory and those sorts of things as well there. So we'll talk a little bit about that as well. So again, from a storage point of view, if you've got a SharePoint site that has a lot of documents, it's predominantly going to be a document library, you should be able to predict the capacity of that. So, Word documents are on average and outside our organization, X megabytes in size. Let's extrapolate, we might have X number of versions, etc. So you should really try to go through that exercise of trying to determine how large the content databases are going to be for the different site collections, document libraries, etc. there. But the point that I wanted to make is that storage is fundamentally cheap. So you can buy 4 terabyte disk drives, 3 terabyte disk drives for a very, very cheap price. So in most people's cases, storage, as far as capacity is concerned, is really not an issue there these days. Okay, you can buy PCIe SSDs, you can buy SSDs, which are really, really affordable these days. So when you're capacity planning for SQL Server, of course the volume of data is important, but what you really also need to try to capacity plan for is the performance that's required. And that's the one that we sort of don't don't think about. So we sort of capacity plan for the size, but we don't capacity plan for the storage requirements. And again, for a larger environment, you're going to have to go through that particular process. Unfortunately, you'll find that everybody on the internet sort of talks about the importance of planning for the number of IOs per second that you have for your SQL Server environment for SharePoint, but nobody's giving you a lot of guidance really as to what sort of metrics and what formulas you should be applying. So again, it depends a lot on your SharePoint environment, and I'm not going to give you any formulas or anything like that. But the idea here is that, if you look at it from a SharePoint point of view, you're thinking about requests per seconds that are going through your web farms to the SharePoint infrastructure. Whereas if you look at the SQL Server point of view, as far as performance capacity planning is concerned, you're thinking more about IOs per second that can be delivered by SQL Server to the applications requesting that. So the problem here is that we don't really have some good formulas for you to work with to try to capacity plan the IOs per second for a SharePoint environment. So there are different formulas that you can apply, but as I said, you'll have to talk to me offline about that. So I just wanted to point out that if you are serious about how you're deploying SQL Server for SharePoint, what you should be doing is taking advantage of two tools. So I've listed them up here. You might have heard of them. The one down the bottom I'll just talk about initially, and that's SQL IO Sim. This is not a performance capacity planning tool, but you should be running that on all of your SQL Server installations because it's going to make sure that the storage subsystem works with SQL Server. Because you might run this particular tool on a SAN, LUN, whatever the case is, and you might start to get errors. So there's something wrong with that data path potentially. So it might be firmware, it might be drivers, it might be, I don't know, whatever the case is. But there's something wrong with the subsystem, if you like, there. So you should be, as a general practice, running that against your SQL Server installations there. But it's not a performance capacity planning tool, it's a storage validation tool there. So you should be doing that in all of your SQL servers. The tool that you can use to capacity plan performance, so how much our storage subsystem can deliver in terms of performance, is something called SQL IO. So it's a very, very primitive tool, but effectively what it does is it simulates SQL Server's IO subsystem, if you like, there. So the idea here is if you have a machine with, I don't know, let's say four CPUs, what I would probably be doing is running the SQL IO tool and telling it to use 4 threads and try to see how many IOs per second we can deliver. What's the throughput of our storage subsystem? Now, it's a little bit more complicated, but at this level, SQL Server performs 2 fundamental types of IO, 8 kilobyte IO and 64 kilobyte IO. So that's what I would be testing, just to see what the storage subsystem can deliver. And that's also another very important point, because in the future you might have performance problems and you need to identify what's the cause of the performance problems. And inside SQL Server you can quite easily see that right now our storage subsystem, our queries against the databases on this disk drive, are giving us 30 megabytes per second. Is this a good number? Is this a bad number? You don't know. You only can deduce something from that if you know what the storage subsystem can deliver. So if you know that your storage subsystem can deliver 300 megabytes per second and you're having performance problems, and you can see right now we are doing 30 megabytes per second, then we know that it's not the storage subsystem that's the bottleneck in this particular case there. So I would highly encourage people to go through a very simple exercise of just trying to benchmark and create a baseline for the storage subsystem and what it can do, because it'll help you to troubleshoot in the future. Okay, and again, I can talk offline about some different test combinations for SQL IO if you're interested after the presentation or offline. The other thing that I just quickly wanted to point out is that you need to be aware of the different software technologies and their limitations. So again, just be aware of the fact that SQL Server 2012 has gone to core-based licensing. So again, what I would be recommending for customers is to buy CPUs that have less cores but run at faster frequencies, because it'll reduce your licensing cost and probably give you better performance for the amount of money that you're actually spending. So right now you might not be using SQL 2012, but you will in the future. So just be aware of that, because otherwise you might get a bit of a surprise when you upgrade your licensing there. The other thing that I like to point out is that from SQL Server 2008 R2, Standard Edition only supports 64 gigabytes of memory. So you might have a server there with 192 gigabytes of memory. SQL Server Standard Edition can only use up to 64 gigabytes of memory. However, what you can do is you can install multiple instances of SQL Server on that particular machine. And then you can put content databases into the different instances of SQL Server. So you should be starting to plan these sorts of things, these design decisions, from the very, very start. And the other thing that I'm doing for customers is highly recommending that you go to Windows Server 2012 Standard Edition, because they sort of got rid of all these hardware limitations of Advanced Server supports this amount of memory, Enterprise Edition supports this, Data Center supports this. So now you can buy Standard Edition and you can support a phenomenal number of CPUs and memory, and they've improved other technologies as well. So I'd be using that to run our infrastructure, if you like, there. So let's move on to configuration. And I just basically wanted to point out that I'd like to highly encourage people to develop what we call a standard operating environment. So I don't know how large your organization is, but I'd be recommending that you try to deploy SQL Server exactly the same way on all of your machines. Because it's quite simple. It's going to help you in administration, performance, problems, troubleshooting, optimization, etc. So everything is set up exactly the same way, or you might have a couple of different SOEs depending on your environment, but try to do that. So a lot of the advice that I sort of give inside this presentation can be used for that. So install SQL Server, this is the default installation, and then we change these 10 things, etc. And that's the way you deploy SQL Server inside your environment. Documentation is always important. So have a build guide, how it was installed. Have a run book. We changed this on this particular date. On the next day, we change this particular setting. Because if you want to troubleshoot performance in the future, you can see it might be as a result of this configuration change being made a week ago or a month ago or whatever the case is. This can be a simple Excel spreadsheet. Date, command that was run, outcome, who ran it. Simple as that. It doesn't have to be a complicated system. So let's talk a little bit about some configuration best practices for SQL Server for a SharePoint environment there. So this is a number of user rights that you should be giving to SQL Server. So this is actually a Windows configuration. So you should be going inside your Windows environment and giving the SQL Server these particular user rights. So the first one is called Perform Volume Maintenance Tasks. And what this gives SQL Server the capability of doing is taking advantage of some technology that we call instant file initialization. Because by default, when you create a database inside SQL Server, and let's say it's 10 gigabytes in size, what SQL Server will do is create this 10 gigabyte file, and then it has to write zeros to the entire 10 gigabytes. If you turn on this particular feature, it bypasses that second step. So instead of taking maybe 10 minutes to create that 10 gigabyte file, it'll create that 10 gigabyte file in 1 second. Because all it's doing to the file system is saying create a file, but don't zero out all of the actual file. So that's going to improve performance of database creation, automatic growth of databases as you put more stuff into the content databases, backups, restores. It doesn't apply to the transaction log. The other thing that I generally recommend, again, your mileage might vary, but I recommend that you give SQL Server the right or the capability of locking pages in memory. So give SQL Server some memory, give it the whole 64 gigabytes because you're using standard edition on a machine that has 192 gigabytes of RAM. So give it 64 gigabytes and tell it that it can't be paged out. So that means that that 64 gigabytes of RAM is reserved for SQL Server. If SharePoint's running on that machine, it's not going to steal memory from SQL Server. Okay, it's not going to page out and therefore give you bad performance. So very, very simple things, as I said inside this presentation, that can give you very good benefits as far as performance is concerned. And as I said, you can use these sort of tips to develop your standard operating environment, if you like, there. Let's talk a little bit about storage as well. So I'm not going to talk about all of these things in depth there. Of course, the right hardware and the right level and the right RAID level is going to make a difference. So make sure you understand the technology there. Otherwise, as far as the best practice is concerned for SQL Server, I'd be recommending that you format volumes that are dedicated to SQL Server using 64 kilobytes. Okay, the default sector size is 4 kilobytes on the WinT platform. Make sure your partitions aligned. You shouldn't have to do that, okay, since Longhorn and Vista, okay? It should do it automatically for you. But in some cases, people are upgrading from earlier versions and you might find that your partitions are not aligned. If that's the case, you can have a 30% degradation on the performance of your I/O subsystem, okay? So it can be quite substantial. So again, just research that if you need to. And the last thing that I just wanted to point out is that with Windows Server 2012, they've got a new file system called REFS, Resilient File System. SQL Server doesn't support it for databases and transaction logs at this particular point in time, but you can store your backups. Your SQL Server backups can go to an REFS partition. And there are a number of benefits with REFS partitions in terms of how it works. It's much more resilient. It performs a lot better. Backups are important. Your database has crashed, you can recover from your backups. So you want to make sure that your backups are as good as possible. So again, I would be highly recommending having a look at REFS for storing backups if you like them. This is another very simple thing that can give you a dramatic improvement in performance. By default, when you install the Windows operating system, if you go to the power plan, it's going to be balanced, which is trying to conserve power, okay? So for a SQL Server environment, you should be changing it to high performance. So your CPUs are going to run faster and hotter, but you're going to get much better performance in that particular case. So again, very, very simple configuration task. So not optimal for SQL Server. This is the default for a Windows Server install and a Windows operating system install. So again, for the servers, consider changing the power plan to high performance. As far as SQL Server's configuration is concerned, there's probably two things that you really want to change. The first one is the maximum degree of parallelism, which is how many CPUs SQL Server will use internally in parallel when it has large queries. For something like SharePoint, we don't want parallelism, because most likely in SharePoint, you have a lot of people coming in and accessing, document libraries, lists, etc., etc., etc. So instead of one person having a process that consumes 10 threads, I'd rather have those 10 threads servicing 10 people concurrently at the same time. So in SharePoint 2013, it doesn't even want to install unless you have this option configured. But the optimal setting for the maximum degree of parallelism is 1. And that's not the default for SQL Server. Okay, so again, make sure you change that to 1. The other thing that you would be advised to do is also set the maximum server memory. And this is particularly a good example of where if you take advantage of that locked pages in memory, you need to use this. So you're using Standard Edition, it supports 64 gigabytes of memory, lock pages in memory, and tell it to use the maximum of 64 gigabytes. In that particular case, I'd also be saying the minimum server memory is 64 gigabytes. So SQL Server is going to consume up to 64 gigabytes, and then it's not going to release that. So again, no performance problems there with things paging, being swapped out, those sorts of things. I haven't really bothered with this one, but I just thought I'd mention this last one. There's a new option inside SQL Server that you can turn on and then get notified, or it writes to the error log, when a process is blocked for more than X number of seconds. So you might want to also take advantage of that. So the idea here is, I don't know what number you should be using, but maybe start off with a value of 10 seconds or 20 seconds. And if you're getting too much chatter, then adjust accordingly there. But what you can do is basically tell SQL Server that if something inside SharePoint is taking longer than 10 seconds, a query is waiting, it's going to write to the information to a log file, and then we can analyze that and try to work out what the issues are there. So again, just be aware of that. As I said, you need to be careful with that particular parameter with what value that you have. There's been a lot of debate in the industry about how to configure TempDB for SQL Server. Let's simplify it. It's quite simple, really, okay? Your time is precious. It's as simple as this. For TempDB, create multiple database data files. Make sure they have the same size. Make sure the initial size is a good size. Start off with 1 gigabyte. Okay, that's good enough. And make sure that the automatic growth is in megabytes and not a percentage. And make sure you have the same automatic growth parameters. And you're going to get the best performance out of that SQL Server as far as the TempDB subsystem is concerned, which is a temporary database that SharePoint uses a lot. Now, the big argument in the industry is, well, how many files do I create? Let's simplify it. If you have a small to medium environment, create 4 database files. If you have something that's larger, create 8 database files. That's your starting point. And then if you have further performance problems, then you can adjust these values up or down as the case might be. So for smaller environments, 4 database files. For larger environments, 8 database files. And it's really a relationship between the power of the server, so how many cores, with how it works with TempDB. So I just sort of put in 4 to 16 cores, 4 database files, 16 plus cores, 8 data files there. No point in creating multiple transaction log files because we use that sequentially. So you've got no concurrent usage of 2 files. You're not going to get any benefit there whatsoever. And again, the default for SQL Server is to create like a 1-2 megabyte TempDB file database. So very, very simple, optimal performance for SharePoint. The other thing that I'd recommend people do in terms of a best practice is change the error log. So by default, you only capture the last 6 logs. So what I would be doing is telling people to change that to 99 because you're having performance problems. So people reboot the server. Then again, you're having performance problems, you reboot the server. You might reboot it 10 times per day. Then you call up an expert to get them to come in and troubleshoot the problem. What's the problem? The important information about what's causing the problem might be in the file that's now being deleted. So I would highly recommend that you change the default from 6 to 99 and you archive these. Okay, so keep track of what's happened for your SQL Server. It's going to help with performance tuning, troubleshooting, those sorts of things like that. So just changing the standard default installation for standard operating environments. The other thing that I don't see being done well in the industry is getting SQL Server to tell you when things go wrong. It's really quite simple. It'll take you 5 minutes to set up email integration with SQL Server. Okay? And then what you can do is tell SQL Server to email you, to generate an alert and send you an email when particular serious errors occur. So again, what I would recommend in most people's cases, this is your starting point, tell it to automatically generate an email and send it to you when you have an error that's of severity level of 17 and greater, because they're the fatal errors inside SQL Server. And then what I've also included in this particular case is these 800 errors and a few other errors. And they're important because they're indicating that your disk subsystem, your storage subsystem, is potentially failing. So you might have something just completely, utterly dying as far as the disks are concerned, whatever you're doing. So you want to be notified of that as soon as possible. And then you can see another no-brainer, database file full or transaction log full. Although, of course, it'd be smarter to be notified when the transaction log is 75% full or the database is 75% full. So you can set this up as well inside SQL Server. The other thing that I recommend as a standard install for SQL Server is to change the history of jobs running inside that SQL Server environment. Because by default, we limit the size of the history log to 1,000 rows and 100 rows per job. So generally what I do is remove this particular checkbox. Okay, so then again, you've got a history of what's happened to this particular machine, which will help with troubleshooting and seeing performance over time. Because last year, a particular job took 20 minutes to run. Now that same job takes 2 hours to run. Why is that? Is it because our databases have increased in size, or we've got more people coming into the system, or we've got some other fundamental problem potentially there? So again, you're giving yourself more insight into potential problems inside the environment. These here are a no-brainer, simple to implement, but you still see people doing this inside the industry. You will get the best performance out of your SQL Server environment if you separate the data files from the transaction log files. So data files are sequential and random I/O. Transaction log is fundamentally sequential I/O. So if you split them up onto separate disks, separate volumes, whatever you want to call it, you're going to get better performance. More importantly, you also have better recoverability. So depending on what fails, if you have separated the transaction log onto another disk from the database files, if your database files crash, something goes seriously wrong there, you can recover what's inside the transaction log, so you will lose no data whatsoever. And you've done this because you've separated the data and the logs in this particular case there. So always do that as a best practice, because you then have the best chance of recovering things without data loss there, because you can back up the log tail, as you can see. Now again, make sure you understand this process, document it and practice it, because when things crash, this is not the time to learn how to back up the tail of the log to try to recover all the documents that were inserted into SharePoint between 9 o'clock and 12 o'clock when this particular problem occurred there. The other thing that I see a lot of inside the industry is sort of people run out of space and start to perform backups onto the transaction logs drive. Don't do that, because if that drive fails, you've lost your transaction log and you've also lost your database backups. So now you're in a really bad state. So separate drive, ideally a separate drive from your backups. You can do it to a share on another server, etc. If you need to, then back it up onto the database drive, but try not to put it onto the same drive as the transaction log, if you like there. That's probably the worst case scenario in that choice of evils. Some more database best practices. The best thing to do really is to pre-allocate the database files. So you're going to have a content database, and ideally, if you can afford to, depending on your storage, make them all 50 gigabytes in size or 100 gigabytes in size, whatever you decide upon the standard. Okay, so you know that content database always has that capacity. Nothing can be stolen from it. So again, that's going to give you the best performance. And then you don't have to worry about file fragmentation. As I said, storage is cheap. I've seen a lot of advice, you should get disk defragmenters. Forget about that. There's no need for that inside SQL Server. There's different types of fragmentation, but you generally shouldn't do that. So the idea here is it's best to control what's going on inside your environment. Don't let SQL Server automatically grow the files, because you'll find that one thing, the third bullet point, is your transaction log can grow in small increments very, very, very quickly. So what happens internally is that you create too many what we call virtual log files, VLFs. And then what happens is that your performance will suffer, and when you start up SQL Server, it'll take longer to start up the databases. So again, we like to see good sized databases, and if you have automatic growth in nice big chunks, not like 10% or 1 megabyte, that's not going to give you good performance. But that's the default behavior of SQL Server, because Microsoft don't like to change the default behavior from version 6 when it was defined. So again, simple things give you very, very good performance. And again, try to control the size of the content database. And this is not really from a performance point of view, although there is performance considerations. It's simply I/O, laws of physics. If you have 1 terabyte content database, it's going to take a long time for you to restore it, and you can't do things in parallel. So you might be better off with 5 200 gig content databases instead. So try to come up with some standards for the organization, monitor these things, try to pre-allocate them, and then this is the way we manage our SQL Server infrastructure for SharePoint. Okay? This is very, very important. We're not going to go to it in depth, but make sure you understand the difference between all the recovery models of the transaction logs inside SQL Server. So again, most people will be either in simple, which means we can't do transaction log backups, or in full, which means we can do transaction log backups. The one that I just want to warn you about is bulk logged. If you go to the bulk logged recovery model, you potentially can lose data because of this particular recovery model and your backup strategy. Okay, so depending on how things operate, how things work, depending on what's happening in a timeline, you might lose data if something crashes. So just be careful with the bulk logged recovery model there. So SharePoint has its default recovery models, but in certain cases you need to change them, okay, for high availability purposes and those sorts of things. But please make sure you understand the recovery models for your databases. So just to finish off here, sort of quickly go through administration. Database maintenance, this is what you need to do. Re-index tables and indexes. If you're doing that at a particular frequency, there's no need to update statistics. I see a lot of people using the database maintenance wizard, and they sort of say, back up the database, rebuild the indexes, update statistics, shrink the database, etc. No, bad ideas there. So the point that I wanted to make, number one, is that if you rebuild the tables and indexes every day, there's no need to update statistics every day because the update statistics is done whenever you rebuild indexes and tables. So it's going to save you time if you have large systems there. Make sure you perform database consistency checks and make sure you also have backups and obviously configure that correctly there. Very, very quickly, don't shrink databases because when you shrink a database, you heavily fragment that database, which will degrade performance by orders of magnitude. Okay, so it's generally a one-off operation if you need to, but don't schedule that to occur every day. You're getting the worst possible performance after that particular operation as far as the database is concerned. So just some further points on re-indexing. Over a period of time, databases will be fragmented, performance will suffer. You can go onto any table inside SQL Server, right-click on the index properties and see the fragmentation level. So you have something that we call internal fragmentation, which they call here page fullness, and external fragmentation, which is total fragmentation. Ideally, we want to see as close to 100% as possible the page fullness, but that depends on the table design. As far as the total fragmentation is concerned, we want to see that as close to 0 as possible. So if it's 80, 90%, you're getting really bad performance. Okay, long overdue to rebuild an index on that particular table or index there. So there's also other commands that you can use, but fundamentally, as I said, for most people, it's quite simple. Schedule this to occur every day after hours. What are your servers doing at 11 o'clock? Nothing. Rebuild the index, make sure it's optimal for next day's operations there. But this is one way that you can use to see the actual fragmentation level itself there. So again, do this periodically. Again, you can see the Enterprise Edition can do it as an online feature. And again, do not shrink the databases because if you shrink this database, this total fragmentation will go up to like 97%. Okay, that's what will actually happen when you shrink a database. Make sure you run database consistency checks. So run the DBCC check DB. Why? You could be backing up something that's corrupt. So when you go to restore, it's not going to work. You're going to get errors there. So it's like a check disk for your file system. So you should periodically run that. And also don't forget to run it on your system databases. So the SharePoint databases, but also on the system databases as well. Because if you're not running it on those guys, if they corrupt, SQL Server might not even start up. So you're going to have problems in that case. DBCC has some options to repair. But I just wanted to point out, you should never get into the situation where you need to run DBCC with these repair options, okay? Because if something's corrupted at that level inside your database, your first port of call is to use your backups. So you restore from backups. Because when you're using these particular options inside DBCC to check your databases, its primary function isn't to save your data, it's to get the database into a consistent state. So if it has to drop all of your documents, it will. It'll say goodbye to that table. It'll just wipe it out. okay? And then hopefully that fixes the problem. No, it's going to wipe out your lists. It's going to wipe out this. It's going to drop tables and drop stuff to try to bring the database into a consistent state, so at least it can work with SQL Server. So it's not worried about data salvage. So that's why you should not get into this particular situation. And you do this by having a good backup strategy that you obviously test as well. For disaster recovery, again, just a couple of things. You need to define your recovery time objective and your recovery point objective, which is fundamentally, how long is it going to take to get, how long does a business need for us to get this system online? And also, how much data can we lose? Can we lose 5 minutes worth of data, 2 minutes worth of data, a whole day's worth of data, or no data? Okay? So that's the recovery point objective. Recovery time objective is how long it's going to take that. So once the business defines that, then you can formulate your disaster recovery, your backup strategy around that. Okay? So again, backup system databases. The other important thing, test. Okay? There are always these horror stories, and they're actually true. People haven't backed up for months. Something goes wrong, they go to restore, doesn't work because of a tape head misalignment or whatever the case is. I know of one organization, it's a TV channel, you know, they had a problem because they didn't know that backups weren't occurring for 3 months. And when something went wrong, they went to restore and found out that backups weren't running for 3 months. Why? Because the SQL Server agent wasn't running. So the SQL Server agent needs to be running for backups to be occurring. So really simple stuff, but in that particular case, what somebody did was they changed the configuration option in SQL Server. You need to restart SQL Server, so they restarted SQL Server, but they didn't reboot the machine. They used just stop and start SQL Server. And when you use that technique, it automatically stops and starts SQL Server, but it stops the SQL agent, but it doesn't start up the agent automatically. So again, make sure that the agent is running because otherwise nothing's happening. And that's why you set up email alerts for not backup failures, backup successes as well. So be notified if a backup completes or fails, because no news is not necessarily good news. So just finishing up, just wanted to point out, we're going to look at a session at 3 o'clock on this, but again, commonly overlooked by organizations. So they think, oh, we've got a good backup strategy, that's availability. Worst case scenario, your system crashes, it's going to take 3 lines for you to rebuild and bring things online. Can your business survive 3 days outage on your SharePoint solution there? So again, very, very important to understand that, you know, disaster recovery is not the same as availability, as high availability, and there are very, very simple, elegant solutions that are easy to implement inside SQL Server that can give you high availability as well. And we're going to look at that at 3 p.m. Today if you're interested in that. Okay, so just really wanted to finish off with, you know, on availability, just by saying, you know, you need to understand the technology, choose the technology, but again, if you recognize the need for high availability, you're ahead of the game in that particular case there. Okay, so that's basically it, I think, for the session. So this is just, a list of the high availability technologies that we'll be talking about. So again, we'll be talking about that later on at 3 p.m. So thank you very much for your time. Sorry we've gone a little bit over. If you have any questions, please come up and ask, and hopefully that's been useful. Okay, thank you.